Hello, this is Mitch McCreary, Director of Marketing, and together with Dr. Christine Sun and Dr. Iyad Al-Attar, we welcome you to the Filtration Hour entitled Air Quality Governance, one of the courses offered in our section of Continuing Sustainability in Air Filtration. I'm happy to introduce Dr. Iyad Al-Attar as our chair for today's session, and we have 6 topic-specific experts. But first, who are we at WFI? The World Filtration Institute is a global nonprofit organization, which its mission is to support the growth of global filtration industry and advance the sciences and technologies of filtration and separation processes for a clean, healthy, and sustainable world. We proudly support the industry with a most comprehensive, cost-effective, time-efficient, practical, and flexible education program, the Certified Filtration and Separation Specialist. We service the global filtration market, filtration media and media market and technologies, air and liquid filtration technologies, air and liquid filter testing and evaluation, and new developments, opportunities, and trends. We offer over 32 different courses in filtration and separation sciences, as you'll see here. And now the Filtration Hour. If you have a question, go ahead and ask us on any of our filtration hours. We have a large amount of specialists that we have on our Filtration Hour network. But today, I'm happy to have Dr. Iyad Al-Attar as our chair for today's session with 6 topic-specific experts. I have Dr. Stephanie Taylor, a medical advisor to ThinkLite Air, Massachusetts General Hospital Infection Control and Harvard Medical Insight Health Fellow. And Andrew Guido, Vice President of Sustainability Innovation at Willowdale Asset Management. Peter Cantone, Founder and CEO of Smart Air Defense. Sotirios Papathanasiou currently heads the Global Open Air Standards Committee, an innovative working with unified language surrounding air quality and raise public awareness of its significance, especially indoors. Dr. Vijayakumar, founder and head of AERFIL, and Dr. Thomas Peters, consulting for membrane technology and environmental engineering. But first, see this amazing video. sustainable future worth fighting for. Now, Dr. Peters, would you like to take over?
Yes, thank you very much. Hello, everybody. Let's say like this, all over the world. I think that we have to look at following points. At first, we have a problem. That's air contamination. And the first step should be reduce or eliminate the emissions, even if people that also deny the climate change say it's not necessary. But anyway, it's reality. But the next is, as engineers, to say we search for technological solutions means the implementation of well-monitored air purification technology. Next, please. What we see here is a mirror of the press. And if you see this around the world, you will find similar pictures from all over the world. And the clear indication also from the part of medicine people who say air is a problem. The problem is here, the air. Why? Next slide, please. You see the particulate matter 2.5 micron. This picture has been shown also by Nick Agoplan, our friend, that during the WFI course Air Filtration, April 8. But I think that's an excellent job done by the EPA, Environmental Protection Agency, because it shows very clear the difference if you compare a hair with a PM 2.5. And the problem of the 2.5 particulate matter is they pose the greatest risk because they go through the bloodstream and go into the body. Next slide, please. The problem is, in my opinion, that there are different standards in this world, and we should go to the best one that in this case is really the World Health Organization that allows 5 microgram per annually, and not like other 10, 50, whatever, that are, in my opinion, also a big problem, because knowing that the smallest is the biggest problem, we should also try to go this. I made to say that I owe this picture to Mr. Adrian Peterhans. He is president of the company Clean Air Enterprise, and to Samuel Tabarelli, also CEO of the Clean Enterprise in Dubai, because they help a little bit to find out the relation on the world. Next slide, please. Is the situation, and there is a way, I'm mostly water specialist or water expert, as they say, but we see the same situation. If I have to filter air or water, we have to separate contaminant. And the technological solution that we see here, we need 2 steps more. That's monitoring, i.e. based, as we say today, or machine learning based. And the third is the control of the monitoring, of the accuracy of the monitoring, a plausibility check. And we see one good example, actually, by the way, from the El Paso water utilities in Texas, who convert treated wastewater into drinking water. Yeah, sure, the direct polar use. We needed the situation for many things, but, and that's the point where we see the parallel situation with air, hundreds of instruments measuring the water quality and potential contaminants in real time, and a lot of safety protocols. So we need to identify the change in quality, and there, in my opinion, that's what we have to think. And one more new way is, next slide, please. If we look on the filtration of air, the purification of air, with the ion separator, as you see here, ionizer, so you get high electrostatic field, and this electrostatic allows you this particles collect them on the light on the collector series on the right side, has a lot of positive effects, zero discharge, zero waste, no whatever. But I think most important is also to see, next slide, please, that we can wash the system with ultrasonic baths without chemicals and just get the stuff that you got from the air, all the particles, and you can use it for concrete or other ways, but it's a reuse, so you have really the circular economy in the right way. Next slide, please. And there was an Expo City in Dubai where they have installed this, a gentleman I mentioned before. And you see here the difference between the normal air filtration with filter and the system with electrostatic dimension. And you see there with the Clean Air Enterprise System after the 16th of October. The air was clean. You can really say that's perfect situation with clean air with a simple system, because at least it's old. We use it in many industries, but now it's applied also for these areas. And important, the next slide, please, is also here the point, and I owe this picture to Dr. Yasmin Skanji. She is, as you know, director of SAC and also ambassador of WFI. And this was to say only that you need a good control and a control of the control, by the way, and that's done. Where it is important to say that this system, as far as I know, is built in France and has no dependencies from importance from China, for example, without link. But to say very clear, we need good situations, good possibilities to control the better. Next slide, please. And that is my conclusion, that we say we have a problem that's a health risk. It's therefore good indoor air quality is a must. We can reduce and up to avoid emissions, that's the first step, but we need the implementation of governance-based, well and retraceable monitored air purification technology, for example, electrostatic-based systems. Thank you very much for your attention.
Thanks very much, Dr. Peters. Now, let's talk to our panelists here. We have a few questions here that I'd like to go ahead and address if we could. The first one is, how can we establish and enforce effective IAQ governance frameworks, examining existing regulations, identifying gaps, proposing strategies for improvement at local, national, and international levels? I'd like to start that question off with Stephanie. Dr. Taylor.
Thanks. Can you hear me okay?
Yes.
Well, I started my timer because I'm only supposed to talk for, I think, 1 or 2 minutes. I could talk forever about this. But in my opinion, as a physician, first we have to establish our goals. Why do we have buildings? What are we going to use as our definition of good indoor air quality? And my belief is we need to consider human health first. And what that leads to are indoor air quality standards or metrics that are based on medical data, microbiology data, as well as energy consumption. So to do that, we need to bring together some professional silos that have deep knowledge bases, but are not necessarily eager or easy to work together. For example, we need to bring together physicians and clinicians with engineers, with microbiologists, because we can't do this in silos. So number one, establish our goals. Number two, use medical data as one of the inputs. But another issue is there are no regulations for indoor air quality. OSHA, NIOSH, EPA, CDC, they're best practices and their suggestions, but there are no regulations. And to get there, I believe that in the real world, we have to consider the financial benefits of good indoor air quality. And again, I have 10 more seconds. I think in this country, there are two strategies. One, reduce the legal fear of collecting data that could then be turned around and used against a building owner. Number two, get the insurance companies to give lower premiums to buildings that have good indoor air quality. And I'll stop there.
Okay, Stephanie, you can continue on a little bit if you'd like.
Well, so the other piece of this that I think we're really overlooking is not only the effect of exposure for exposure's sake. For example, the presence of a virus in the air is not something that we want to encourage. But the piece we're not looking at, in my opinion, is what do indoor air metrics do to our immune system, do to our physiology? Because if you consider that dimension, as well as the traditional exposure consequences, things like dry air are very hard on our respiratory immune system. So engineers hate the word humidity. I I don't use it. I use indoor air hydration. But dry air, to some extent, paralyzes our respiratory immunity and makes us more vulnerable. So when we think about building management, we need to think about what air quality metrics are doing to the human being. And the very last thing I want to mention is bringing microbiologists into the equation about determining good indoor air quality standards, because 95% of microbes, bacteria, viruses, fungi, actually benefit us. And so we don't want to have air cleaning strategies that only remove the more vulnerable good microbes and leave the pathogenic ones. So I think we have to bring medicine, microbiology, and engineering, as well as data analytics, into the equation when we determine ideal standards.
Great. Thanks very much. Appreciate that comment, Dr. Taylor. Sotirios, do you have a follow-up on that as well?
Yeah, absolutely. I will agree with Stephanie, and I will say that in many cases we will see people that when they are trying to mitigate pathogens from the indoor space, they will remove, without thinking properly, all of the pollutants, all of the pathogens out there, all the bacteria, good or bad, without discriminating them. And that's another bad approach, I think, as well. So we do need those experts that they can guide us into taking good decisions on how to mitigate those pathogens, whether they are viruses or bacteria, from the indoor environment, and creating an environment where it's going to be it's not going to be beneficial for them to grow, but rather it's going to be an environment beneficial for humans to grow.
Okay, that's great. Thanks, Sotirios. Appreciate it. Let's see, Iyad, do you have any comments on that?
I'll pass it to Peter. I think we've talked about this earlier in the courses, air filtration and air filtration design. So maybe Peter, if you can comment.
Yes, absolutely. Thank you so much for having me on. Real quick, I'm a big believer in the process, and what we have to really pay attention to when we're talking about buildings is the mechanical engineering world, and that's ASHRAE. And we have a standard that was out a couple of years ago, ASHRAE 241. If we focus ourselves, and it's not perfect, there's definitely some additions that need to be added to ASHRAE 241. Particularly, I'm not a big a proponent of just during IRMM, or infectious risk management mode. My focus has been in the K-12 market, so I feel like every minute that the students and the teachers are in class, it should be meeting that 40 CFM capacity per occupant of equivalent clean air. But the bottom line is that we have a standard that's basically the roadmap to get us to much better indoor and optimal indoor air quality. What we need to do is have the mechanical engineering world embrace that, and that's something I'll talk about later on in a different question.
Okay, great, Peter. Thanks very much. Andrew, do you have some comments to that as well?
Yes, thanks, and hello everybody across the world. I agree with Dr. Taylor's comment. We have to move from non-binding guidelines to a regulatory basis, or we're not going to get there. This is almost like almost 150 years ago it was that we had germ theory, and as a result of that, doctors washed their hands. And it's now seems so obvious that should be a solution. We're in the same state with IAQ. We need to wash our hands. We need better adoption. We know what to do. We're one of the first companies that implemented ASHRAE 241 standard in both a new home and in a retrofit to test the standard. And it was not that difficult to do. So I think we know what to do. We just have to get there, and we need a nudge. And we need to move from non-binding to some sort of a regulatory, whether it's through the building code or through adoption of ASHRAE standards.
Okay, thanks very much, Andrew. Vijay, do you have a follow-up to this as well?
Yes, I do. My point is maybe a little bit 180 degrees opposed to other people, more closer to Stephanie, especially for the audience who are not in the Western world. My advocacy is always how much can you get for the least amount of whatever technology you want to implement? Because humans are very resilient. Humidity plays a big part to keep us healthy. So the goal always should be how little, especially when you're looking at sustainability, how little technology or filtration can you get by and still maintain healthy indoor environment?
Okay. Well, that sounds very good. Dr. Peters, could you add something to this as well?
Yeah, I think the last comment was correct, where we are if we look on the air. But even in areas like in India or whatever, where we have been working also, it's not easy, but it's possible to do something, not only reducing the effects of the burning of stuff, but also for cleaning the airs using simple technology. The only thing is that we need more engineers thinking about this one together with the medicines and together with other people. And I think there could be or can be found situations if the people are ready to listen to say we have a problem. But till now, as still there are many people who deny the climate change, you have no chance. So we need to change the mind a little bit on other areas also, and then I think we can find a solution.
I think like Alcoholic Anonymous, first we have to admit we have a problem.
Yeah.
I
Yeah.
agree.
Thanks. Thanks, Vijay. Now let's take that question just a little bit further and say, let's look at part 2 of that question. How can we embed IAQ technology into our urban planning from day one? Dr. Taylor?
Well, my belief is that until we make the issues with indoor air quality and outdoor air quality, which obviously impacts the indoors, until we make it visible, people aren't going to address it and bring it into our building designs. Just like, Wi-Fi, when your Wi-Fi goes down, even though you can't see Wi-Fi, you know the consequences. So I believe that creating visibility around the presence of contaminants or the lack of contaminants, and to get there, I believe we need to really fully embrace air monitoring. If we could invent a plant that turns colors when your ozone and VOCs are high, that'd be great. I don't think there is such a thing. So I think we have to really embrace monitoring at a very early stage.
Right. Couldn't agree more. Air is kind of invisible. We can't seem to understand when it's really contaminated unless it's really, really contaminated. So go
Exactly,
ahead and
yeah.
follow up with that, a little more on that, Stephanie.
Around about the visibility or
About
about
embedding the IAQ technology. How do we govern that? How do we get it involved and make it necessary?
I think, as Vijay said, if we want to take a 12-step approach, acknowledge that there's an issue and we have an air quality issue. And as I watch outdoor air regulations disappear or thresholds become even less good or worse, I think the onus is on building managers to pick up that responsibility. So, my mind just sort of blanked a little bit, but I believe, we need to move beyond this concept that occupant comfort is an adequate measurement of whether or not we're doing things right. Comfort only reflects what we can perceive. You can't perceive radon. You can't perceive excessively dry air most of the time. So I think that we need to acknowledge that there's a huge impact on health that goes beyond what's perceptible. And then to go a little further on that, we have strategies to collect data on occupant health, whether it's a wearable, such as, a smartwatch, or eventually maybe collecting biomarkers around human responses. Create visibility through monitoring.
10:29 a.m.
Okay, great, Stephanie. Thank you. Sotirios, you had some information you wanted to discuss as well.
Yeah, thank you, Mitch. So basically, it's what we are saying so far. Like, we need to bring more people into the picture, and we have to take steps like bringing architects into the air quality. They have zero understanding of, the needs of a human inside in a building and how the building is going to correspond in the needs of the human throughout the year and throughout the changes. And in some cases, we have to work with them alongside, and the engineers as well, in order to create those systems that they're going to be able to enforce good indoor air quality in different buildings. And not only that, I think Adriu mentioned it, like, we need to surpass the guidelines and go through legislation where we actually require everyone to follow certain guidelines around, or standards around, air quality inside buildings, where it's very difficult to find them, especially in a global scale. And even here in Europe, where I am, it's so fragmented that everyone is getting confused. Although the European Union has some framework around ventilation, where they encompass a little bit air quality, they don't provide specific instructions on how or what should look like for the occupants at the end of the day. And then again, the European Union is trying to help countries to develop those different guidelines or standards, but you see that they are still pushing back into coming up with different regulations when it comes to indoor air quality.
Okay, great. Thanks, Sartorius. Peter, do you have another comment there?
Yeah, so me being focused in the K-12 market and in the public places, public buildings, I should say, we all agree that indoor air quality sensors are critically important to get a better understanding of what the indoor air quality actually looks like, right? The problem is that I don't think we have an indoor air quality issue, but we also have a funding issue, because if a school and there's only a handful that have a tremendous amount of sensors out there, if a school's not prepared to fund the issues that they may encounter, that makes them extremely nervous and not wanting to know what the indoor air quality actually it really looks like, right? Because they don't have the funding and they're very hesitant to understand what it really looks like. So the key to some of this is going back to what Dr. Peters had said, is acknowledging that there are very, very cost-effective solutions that can get us to a different point, whereas we have a classroom, for example, that has natural ventilation still today. Hundreds of thousands of classrooms have nothing but windows and a steam heat or any type of heater. The bottom line is there are ways of correcting that using unconventional engineering designs, simple designs, as Dr. Peters has said, and I had some ideas, but the key is that we have to marry the two together, that there has to be an understanding that it is feasible, but we're talking about a fraction of the cost of conventional design, and then we can move into the space of using those indoor air quality sensors to continue to monitor the indoor air quality as you continue to grow in a school building. For example, if there's 10, 15, 25 school buildings and you're starting a test pilot off on one building, you do the correction, you make the correction, you upgrade the indoor air quality, then you add the sensors to continue to monitor the indoor air quality, and you grow from there, the next building on it, et cetera, et cetera. That's a more manageable way, for at least from the public school market, versus the inverse of saying, hey, let's install 5,000 sensors, and now all of a sudden you have people that, we live in a very litigious society, so people love to sue schools for everything.
That's true. That's true. Yeah, do you have a question on that?
Yeah, I just wanted to comment quickly. I agree with Peter on the governance side. I just wanted to say that to be able to govern air quality is one thing. To embed it in the platforms, laws, and regulation, it's totally different ballgame. Right now, we have so many challenges. One of them is the monitoring. Yes, we do have some monitoring. They're not inclusive. We don't have a clear definition of what do we define clean air is. The menu is huge. We talked about this in the past two courses: bioaerosols, particulates, chemicals. How do you widen the lens or zoom in on what you're trying to capture? So, look, if we do not have an agreement on what clean air is, if standards to date have not perfected ventilation rates, filtration stages, efficiencies, if we're still discussing that at the commissioning stage, filtration and air quality is a bit dicey, and we're not sure if optimal air quality is something that would be a deal breaker. You get to your new apartment or a new house, and all you care about is flipping the switches to make sure that you have electricity, you have tap water running, but maybe flush a toilet. But as a consumer or as an end user, you don't look at air quality from that standpoint. So potentially, why should the bodies that govern or help govern air quality look at it this way? I think we have a multiple homework to do. One of them, we still have a homework to do on the integration side. I think Dr. Taylor has mentioned, everybody's sort of designing or working on their own silos. I think we need seamless integration of multiple technologies that in so much or so many terms help serve the optimal air quality we're looking for. So we have multiple homeworks, and I'm sure we're going to be discussing them in the next hour and also in the questions that we've been receiving. Mitch?
Right. Thanks, Iyad. Very good. And I kind of wanted to touch base again on with regards to public schools. I think, Peter, you touched on it a little bit. We have kind of a decaying school system here in the U.S. as far as buildings go. And trying to retrofit those is going to be kind of difficult. And I guess that the school districts themselves will be resistant to that. How do we set up some kind of governing laws for that? Do you know?
Well, first off, we have to have an understanding, as I mentioned before, that I think the mechanical engineering world, they don't think outside the box, unfortunately. And with old public school buildings that are over 50 years old, you have to think outside the box. There is no other way to tackle these old school buildings. And so we have kind of the square peg trying to get smashed into a round circle with some of these engineer firms speaking to very large school districts saying, hey, let's put air handling units on the rooftops and run ductwork through asbestos and lead infested walls and cost millions of dollars for one building that's probably not even worth $1 million. Right. So when we take a step back and realize that that's not the right way, that's not the right approach, and so now these school districts, because that's the only approach that they've been recommended, they're terrified of even touching those school buildings. They focus more on building new buildings, right? So they build one building that costs $300 million. They put solar panels on it, and it becomes this big promotion of we did such an amazing job, which is terrific. But what about the other 500 schools that are sitting there that still are using windows for natural ventilation? So the key is, let's think of pragmatic, practical solutions, classroom by classroom. This isn't emerging technology. You have energy recovery ventilators that are meant to pull fresh air into a classroom. You have HEPA filters, ceiling mounted, not the floor mounted HEPA filters that combined could actually meet and exceed CDC and ASHRAE 241 standards. Not just minimum ventilation standards, right? That's the other thing. We shouldn't be targeting, let's clap and say, we're so thankful that we meet the minimum ventilation standard for these classrooms. We should be going after the 241. That's what just came out. That's what we should be targeting.
Yep, I agree.
Can I say something here, or am I out of
Yes,
turn?
yes, certainly, Stephanie.
So, Peter, I love that you're working on schools and critical population, vulnerable population. I disagree that we shouldn't start with monitoring. I do understand that people are afraid of that. I've seen it in my own work, where people are like, I don't want to monitor because what happens if it's bad? I don't have the funds. I understand that that's a fear. However, it's not immediately obvious what's a healthy indoor air situation and what's not. Some of the vernacular architecture, building materials that have porosity and structures that you wouldn't necessarily think have a healthy indoor environment do. So I think we need the visibility before we start following, ASHRAE 241 or 44P, or start implementing solutions, because it's not clear what's good and what's bad. So I think we need that visibility first. And in my school district, I live in Stowe, Vermont. What I've done is I've taken the monitoring and some solutions to the school and say, hey, let's start a course. Let's have the students understand this intersection between the outdoor environment, the indoor environment, health, and a return on investment for healthy people.
Yeah.
So that's a strategy I've taken.
Yeah. So I just want to say that I do agree with the fact of using indoor air quality sensors as the initial phase. However, I'm just being realistic, being in the K-12 world and what their fears are. I give big accolades for the Boston School District that was one of the first, if not the first, school district that put sensors into almost every classroom. They had over 4,000 or 5,000 sensors, which was tremendous. They got beat up. People were saying they didn't do anything. They just put sensors in. And I had to really, help her out, and Catherine Walsh there, to say that, look, at least they had the courage of doing something, right?
Yeah.
Where these other schools didn't have any of the courage. So I agree with you 100%, but I'm talking about in a practical sense, most of these schools are terrified. And while I agree 100% that the indoor air quality sensors should definitely be the first phase, that's what they were afraid of. That's all.
But then like Vijay said, we need to have in our armamentarium or toolbox, we need to have, an array of solutions. Because you're right, if I go have a colonoscopy, I don't want to be told, yeah, you've got colon cancer, sorry, I can't do anything about it. That's, I wouldn't get the colonoscopy. So I agree, we need tools, but I think we shouldn't go into the tools first.
All right, Sotirios.
Thank you. I share the same experience like everyone else. Like schools in general have a fear of what's the outcome of having monitors inside. But in the majority of them, they fear of the cost that those implementations will have. So I think like a strategy will be to educate them about the benefits of having better indoor air quality and the saving that they will have by having better indoor air quality inside schools. Whether that means that installing air purifiers or having central ventilation systems with recovery units and air quality monitors inside there. So always when we talk about fear is the fact that we do not know what's going to happen. This is the reason we fear something. So let's help them understand what is going to happen if we implement indoor air quality in those buildings.
What about the concept of introducing clean air as a solution, just like water? So have a subscription service so that people aren't faced with big upfront costs.
Okay.
May I comment this?
Dr. Peters.
Stephanie, your last word was water. We should learn a little bit more from what we did in the water business. Please think about that today we produce about 20 million cubic meters per day drinking water from seawater for about 50 cents. 10 years ago, that was $6. So that means only as more people work on this field and more technology is installed, we can get down the costs. Because my credo is very clear, we need more and better technology. And this includes the measuring, the monitoring, and all the stuff. But there are good solutions on the market. And as an independent consultant, just select only what I see as good one And you will see that there are, if you look around, there are few good stuff, good products, but you should select them. And not like we see it in the in the water business, that the big companies try to kill everybody who has a good idea that's cheaper. That's a problem, in my opinion. And therefore, I think, as you also mentioned, architects and these people should be learn more about and should know more about these details. So I think there is a crash course, very good idea to give crash course to people who don't know what's really the problem of the air quality. But the future can be really that we go down with the cost and then we don't have the problems we have today.
Okay.
Thank you.
Thanks, Dr. Peters. So you're saying that the answer isn't bottled air, instead of like we solved the water problem with bottled water. But anyway, Peter?
Yeah, so along those same lines, an interesting idea that popped in, and I saw it in LinkedIn at one point. But the point is that we have public utilities that supply natural gas. They supply electric power, supply water. What about the concept of having a public utility supplies clean indoor air, right? So a utility will come in and do everything, retrofit the building, and the building pays $2 a square foot for the clean air. That meets certain standards. Just an idea I wanted to throw out there that I think that, when we talk about things that are so complicated for certain schools, but for us, it's so clear and easy to understand. I think sometimes having a group like ourselves or a similar group to be able to have that ability to come in and say, let us manage the entire thing, indoor air quality sensors. We're going to upgrade all the systems and have real clean air according to things that we would all agree on. I think that might be an avenue.
Yeah.
Just thinking out loud.
Great. Sotirios, I see you have your hand up, but I think Iyad had something to say about this as well. Iyad?
I just wanted to say, it's a collective of so many feedbacks that I've heard from all the panelists. I think there is more than one segment of the problem here. And just imagine we've been on this question for most of the time. This just reflects how important this question is. And clearly, no one has a definitive answer of how can we embed indoor air quality governance from day one. As Dr. Peters said, there is a technology part. We have to play a role in the technology segment. But let's just go back to the pandemic. What did most governments embrace? When we say it's very, very difficult or almost impossible to legislate or legally bind companies or facilities with the optimal air quality metrics. Well, let me remind you that it took governments no time to mandate masks. And in one way or another, that was the answer for the pandemic, the immediate answer for the pandemic. I think we're, hopefully not in a pandemic time, so we can go back to the drawing board and ask ourselves, what other non-filtration maybe elements that we need to look at? Street canyons today are an important element ailing city design and urban planning. Let's solve that. Anthropogenic emissions. We pollute so much, and then we have to deal with all the pollutions, that we have to, kind of capture it through filtration. So I think what we need to do, we need to sit all on the same table, address it from different angles. But right now, I'm afraid I don't think we have a comprehensive solution. And one seat we have to reserve for the government, because the government cannot give us fresh and clean air, but the government, certainly any government can help accelerate, legislating this. Thank you.
Yeah, that's correct.
Thanks very much. Appreciate it. Vijay, you had your hand up?
Yeah, here is a challenge to the panel here and maybe people in the audience. We are the brain trust, or so we claim. My view, I've been in another panel too, the issue, the problem why we've not made any progress in getting some uniform code or something for indoor air. there's no evidence on the outcome. We do all these wonderful things, add filtration, add monitors. Where is the evidence saying this is improved or not improved? If you go back to outdoor air quality, ambient air quality standards, I was involved in collecting data for the EPA in the 70s and 80s. They had a 7-8 years worth of evidence or the outcome testing in their labs before they promulgated the standard. So maybe we all should take a little step back and spend as much energy trying to collect the evidence of the outcomes of the solutions we are providing before we embark on getting more and more technology, more and more monitoring, more and more whatever we want to do. Then we'll find people will get on board. Like Dr. Peters was saying, water, people start wanting clean water because there's good evidence. If you have contaminated water, you fall sick.
Okay.
Cause
Thank you,
effect.
Jay. Thanks very much. I do have a question here from the audience, and I just wanted to, it's a threefold question. So let me pose this. So we talked about indoor air quality monitoring. How do we independently evaluate these monitoring systems? I mean, who's going to monitor the monitor, so to speak? Because bad data means bad decisions, right? Anyone have some input to that?
Yes, I believe that one part, at least the first of the evaluation was done in one of the recent ASHRAE research projects that compared all the available monitors to see how good or bad they are against laboratory quality reference instruments. I don't remember the entire data. In general, the less expensive the monitors, the less good the quality of the data. It's quite common sense, but the more you pay, the better you get.
Sotirios, you had input to that as well?
Yeah, we have to understand that those low-cost sensors, they come with limitations. So far, we have figured out those limitations and we can work a little bit around them. So we can get very valuable data outside of those low-cost monitors. Currently, there is an agency in the US, in the South Coast, called AQSpect, that they do evaluations of those kind of monitors for indoor and outdoor solutions. They provide all the information for free. From my experience, they are completely transparent, and their work has helped me and others understand better those sensors and making the right decision when it comes to like purchasing one of them.
Okay. Thanks, Sotirios. Anyone else have some input to that? Okay, so if we were to go ahead and talk about indoor air quality, improving the indoor air quality, how would you suggest that we educate the public on that? Anyone?
Yeah, I think it's evident that the medicine people have to start at first to show really that is a problem and how many people die really about this one. Because as I showed the picture, the mirror of the press, you see many all over the world, the press is asking how many people die and whatever, but the reality should be underlined by people who are on the medicine sector, and they should show the evidence of this project, what was mentioned, discussed before. And I think the way is only to open the eyes to the people and to say, yes, you have a problem. We are lucky to live in a world where it's here clean air, but if I see other areas where we are also traveling and see that these people really take a mask in the bus to avoid the contamination. But that is my opinion. The first step is the medicine people who have to give alarm and say there's a problem. And again, not the people who deny the change of the climate. That's an issue that we have to discuss about very clear. Thank you.
Okay, all right, Sotirios.
Thank you. I've been trying to do that for many years now. So I'm trying to educate the public around air quality. I also believe it should come from the medical scientific community as well, as I have been encountered multiple times with medical staff that they haven't linked yet that air pollution has certain outcomes to the human health. And it's not only about death, because in many cases you will see headlines saying like 7 million deaths annually in a worldwide due to air pollution. But it's also very important to consider the health implications air pollution has to the individuals, hospitalizations, dementia, a lot of health problems that could be easily, eliminate, but because of the fact people are not aware of how important air quality is for them and for everyone, they just don't realize what they have to do in order to address indoor air quality. And earlier we talked about the analogy of water and air, right? What happens with water is we can see it. So if I see dirty water inside or particles floating inside my glass of water, I won't drink it. But with air, we don't do the same thing because they are smaller and we can inhale them and we just ignore them completely. And we have to create this mentally shift inside our head. Or even with smells and odors, right? Like we have create a link inside our heads, believing that something that smells bad, it means it's bad for our for us, for our health. But when something smells good, then it's something good for us. And this is the reason all of those cleaning products have like an array of fragrances inside in order to mask the real odor, right? And make us believe that it's something good for the indoor environment and let's spread it all over and breathe it, which is incorrect, right?
Right. So Stephanie, I'm going to ask you to comment, and then we're going to have a little bit of a break here for a moment. Stephanie?
So I 100% agree that the medical community, and from my perspective, physicians should be much more involved in environmental hygiene. Unfortunately, prevention, at least in the US right now, is not profitable. We're still in a fee for performance rather than we're still in a pay for performance rather than value-based care. So until the financial model shifts, I think it's, most physicians aren't interested in environmental prevention. So in my work, what I've been doing is strategizing like what buildings I move into first. Acute care hospitals are very hard places to get data, but where I've had really good success is in senior living communities, because the business model of the senior living community is more aligned with keeping people healthy. It's like keep people healthy and then they'll die quickly, but don't have them going back to the acute care hospital, coming back to the senior living community, having them have cognitive decline that's associated with air pollution. So align the models. And the last thing I want to say is if we could get clean air as almost like, or filtration or monitoring as a prescription. Dean Ornish 30 years ago got the heart healthy diet prescribed. So insurance companies would cover the food in that healthy heart diet. We need to get insurance companies, in my opinion, involved in reimbursing people.
Agreed. So right now we're going to take about a 2 or 3 minute break, and we'll be right back. Okay? Thank you. righty. Ready to get back to this again. I'm gonna start the second half here, or the last 30 minutes we have, with this question. Beyond policy, how can we focus on the practical applications of filtration technologies in our environment today to mitigate problems and issues? Anyone have something on that, Andrew?
Yeah, thank you, Mitch. So I've been doing a lot of testing in the work that I do, heading up for a builder, sustainability and innovation. And I think the first thing is what Peter was talking about, is we got to shift from the attitude from being minimalist to being optimists, doing optimal solutions with it. And you know, we're very fortunate, because I don't think the gap right now is about technology or about how to do something. The gap is, do we want to do something with it? And if we look at, starting, I like to look at things as from a hierarchical level in terms of where can we have the greatest influence? Well, most of the outdoor air we consume is indoors because of infiltration. And so if we can get the what we do outside of our homes, we talk about the planning and making sure that we properly separate road systems from backyards, so that we're not breathing in all of the dust from the roads and from the cars and everything coming into the house. And we have better design, so we have walkable communities, and we're getting out there. It'll help. As we move indoors, there's so many small little things that we can do that really have like a fractional cost, moving from MERV 8 to a MERV 11 filter, and then ideally to a MERV 13 filter, designing right from the beginning that little bit of extra horsepower you need to overcome the static pressure difference. It's really very small, almost like in the cost of a home. It's a decimal point to be able to get there. And then ultimately adopting, HEPA-like filtration solutions. And there's funkier stuff that we can get to with technology, but there's a lot of solutions that are at hand that are well within reach of most people. But it would only happen if it's available, and if we move from the mindset of going from minimal to optimal. What can we do that's out there?
Agreed. There was one comment here from the audience, and I just wanted to kind of throw that up to y'all. We have a lot of contaminants in the environment now. We talk about removing microbes from the air and possibly destroying good ones. Natural response is for a layman to give up. I mean, they don't know anything about IAQ, so anyway, go ahead, Dr. Taylor, go ahead.
So I just want the giving up part. That's a tough one to answer. But before that, I wanted to reiterate the importance of moving away from very dry air. Dry air incapacitates our ability to fight illness. So even though humidification and managing your humidity to the mid-range zone, 40 to 60%, is hard or sometimes impossible given thermal channels in buildings, acknowledge the value of water vapor for human health. It helps the indoor microbiome. It helps our respiratory defenses. It diminishes the natural selection of pathogenic organisms that can survive very dry conditions. It decreases the airborne transmission of antibiotic-resistant genetic elements. Water vapor in the mid-range is very valuable. In terms of the giving up, I don't know what to say. I know that feeling, but again, create visibility around indoor air quality, and as Vijay said, get the most bang for your buck. I don't know how else to answer that question.
Okay. Thanks, Dr. Taylor. Peter.
May I add something?
Yeah, go ahead, Dr. Peters.
Stephanie, you're correct if you say we need humidification of the air. Dry air is difficult. But the problem is that the people who are engaged in this don't check the quality of the water, because with the humidification, maybe you introduce more bacteria in some areas where they don't care about the water coming from. So again, we start with more technology, more sensors, but it's the only solution we have, being more and more people on this world. And the humidification is surely the correct way, but we found many, many years ago already that you need good water for this one. If not, you create in your circuit loop, you create more bacteria, and then they go to the air, and then you have a problem. So it means that we have to go one step back again and look on this one. And that's what I think the medicine people like you know, and they have to put the finger and say, hey, please be aware of the step number 1, and then before you go to step number 2, if you make this comment. Thank you.
Okay, thank you. Peter, Cantone?
Yeah, so when I look at the more newer buildings that have air distribution, proper ventilation, and moving to MERV 11s and MERV 13s, that's all good. But that's still just basic indoor air quality. Like, that's kind of minimal, doing minimal stuff. When we're looking at really taking the next step into the future, unfortunately, the ionization world got a very, very bad black eye from the needlepoint technology that's out there, through class action lawsuits, et cetera, et cetera. The reality is there are different ionization technologies that are out there. One in particular, the dielectric barrier discharge, BPI, is actually very, very effective. And the beauty of that technology is the fact that you're getting a tremendous amount of more added value per dollar investment. In other words, it's not just it's breaking down VOCs, it's inactivating viruses and bacteria, mold, and also taking particulates out of the air. There's not, and that's in the space that it's entering, not in the air duct, not by the filter, in the actual space. So you can't get a more proactive type of technology than that technology. One of the areas where we had a lot of pushback, obviously because of the lawsuits and whatnot, is what we did to kind of differentiate ourselves is actually bring in a third-party engineer to test the air before and after. This was an engineer, very credible engineer, been around for 30 years, Group DeConzo Engineering. And they actually brought it to our attention because they did so much testing in the needlepoint area and were not impressed with bipolar ionization. And so they kind of, it was kind of well, let's see what you have and let's test it in real world in a classroom to actually see if it's going to work. And they were blown away. And so we have to start looking at those technologies and start to try to differentiate and really separate ourselves from the mud that's out there, because there are technologies that are considered emerging that aren't good, and then there are that are very good. So that's part of the challenge that we've encountered with these new technologies.
Okay. Thank you, Peter. Very good point.
Yep.
Andrew,
Yes.
do you have a comment on that?
Yeah, well, I think, it's a systems approach. No one thing by itself is going to take care of it. Ventilation, upping it from the minimal standard, because I think most homes are underventilated, or most buildings are substantially underventilated, and ventilation plays a very big role. I think way outside its weight class with what we do. The filtration, as we talked about, the monitoring of what you're doing. A lot of this has come down within costs that are within reach of most people at this particular point. There's some, more exotic solutions that are more expensive, but I think we have the means, as I said before, we can get most of the way there if only we would want to.
Okay, thanks, Andrew. Sotirios, you had your hand up.
Yeah, I wanted to comment on the original comment from Stephanie around humidification of the indoor space, which I do believe as well it's very important, keeping the humidity in a certain level, between 40 and 60%, let's say. And I saw that while I was living in the US, it was constant there, like a problem. And the main driver for having a dry environment in the indoor space was the HVAC system designed specifically to provide heat or cold and nothing else. Like they didn't care about how humid the air would be, but rather how hot or cold would be. So maybe we need to shift a little bit our attention towards that direction and help those experts in that area understand that they also have to look how they can maintain the environment in the right humidity.
Okay, thanks. Good input, good input. Iyad, did you have something to add to that?
No, I think Dr. Taylor had her hand up.
Yeah.
So
Oh, Dr. Taylor, I'm sorry, I just saw that pop up. I apologize. Go
Oh,
ahead.
no, I always have my hand up, it seems. I love what you just said, Sartorius. And I think that we also, you know, a shift in our mindset about building use would also help us protect vulnerable populations. And what I mean by that is, if I look at, I love to look to Mother Nature for guidance. And if I look at, for example, a beehive, the most vulnerable population is not going to be on the exterior of that. So if we want to consider humidification, for example, and you have a building envelope that's got thermal channels, so there are risks associated with humidity beyond what we already talked about with good, clean water. Put the most vulnerable populations, say in a hospital, in the core of the building, you know, forgo views of nature through windows, put holograms on the walls. Let those people go home and view nature. But I think using building spaces in a hierarchical way would help us protect vulnerable populations. But that's a mind shift. And the other thing I wanted to mention is I look forward to the day when building materials such as, you know, bricks, untreated wood or concrete is brought back into our indoor environment so that there's more material porosity that can help manage water vapor levels. But I think, you know, structure and function need to come together again, you know, using desiccant technologies and building materials to help manage water vapor. So
Thank you.
hierarchical building use and building materials contributing to good indoor air quality beyond just reducing VOC emissions from bad stuff.
Okay. Thanks, Dr. Taylor. Andrew.
Yeah, I just wanted to add to Dr. Taylor. So we started playing with hygroscopic building materials in order to be able to create some passive solutions. Most of us in the building industry put in shiny objects, things that cannot possibly absorb any moisture level whatsoever. And so, you know, materials like, you know, certain plasters and cork and unfired bricks and woods and so forth, they've got to make their way back into our designs so that we can help regulate some of that moisture both on the high and the low side.
I love that.
Good point. PJ, do you have something you want to add?
Yeah, I mean, echoing what Andrew was saying is, bricks, I don't know why, bricks are fantastic devices. They are antimicrobial and they are a regulator of both thermal and moisture. Way back, you know, my dad was a surgeon in India and his surgical theater was brick-faced. And he had no air conditioning. It worked pretty good. I think we need to go back. I think there is I forget his name. There is a person who writes a lot at the ASHRAE about buildings. He's a Canadian but lives in Boston. We need to look at building as a whole, not individually for air or humidity or everything else. We need to start from the ground up. Then we probably will get a good solution if we add to that the evidence. Say, if you did this, this is the outcome. And that's the hard part to measure.
What do you mean, VJ? Why is that hard to measure, the outcome?
You need to have a double-blind, independent, verifiable test or a study to say if I increase this by so much, this is the outcome. Right now, it's all anecdotal, whether it's in the ASHRAE standards or anywhere else, yours or mine. We know it works.
I think
But-
that brings us full circle anyway to deciding what our ultimate goal is.
Right.
And
Maybe
again,
I
think
made
it's-
that point, when we did the outdoor ambient air quality standard, the PMs and the statutory pollutants, 7-8 years of measurements, and then we had actual data saying if you increase it so much, this is the outcome, both epidemiological and lab studies before the standards were set. We are in that stage, like Dr. Peters was saying, we are like water was way back. So we know how to collect the data. We don't have the patience or the inclination to collect the evidence. It's painful work. Science is not overnight.
Okay, thanks, Vijay. Iyad, you had raised your hand?
Yeah, I just wanted to kind of bring the conversation back to governance, which is the topic of this filtration hour. We've got, I think, 10 minutes left. So I think there are a lot to be covered on that segment. If we can just address other topics, because we want to discuss policies as panelists today with your tremendous experience, what novelties we can bring to this topic so we can raise the bar of air quality and even governance so that people can actually, attain and maintain air quality in their indoor spaces. Mitch?
Agreed. How do we move to active IAQ monitoring instead indoor?
Mitch, it goes back to the same thing. Governance is what we need, but what are you going to govern with? What is your benchmark? We don't, until there is unanimity or everybody agrees this is what we need, it's not possible.
And if you allow me to add on that, this is the reason we created, for example, the Global Open Air Quality Standards Initiative, in order to facilitate that, like getting people from a variety of backgrounds together in order to come to a conclusion of what air should look like, what are the limits we should use for the indoor space, and help people, not only the everyday people, but even the academics. Sometimes they struggle to navigate this crazy world of standards and limits and what they encompass in general when it comes to air quality.
So I think what you're saying is that we need to have more control over these types of environmental issues. Is that what I'm hearing, Sartori?
No, it is the fact that we are very scattered. Everyone is working on their needs, and they do not take the time to zoom out a little bit, connect with different fields, and come all together in a conclusion on what should we do to establish good indoor air quality inside buildings. Whether this building is in the US or is in India, it doesn't matter. The buildings are meant for humans, and all humans have the same right for clean air and the same needs at the same time.
Okay, agreed. Any other comments on this?
Yeah, if I
I
can.
Oh,
Andrew,
go ahead.
Go ahead.
Okay, so yeah, so I think this is almost like reminds me of Terminator, the movie, the Arnold Schwarzenegger movie, where they go back in time. I think 25 to 50 years from now, when we look back and say, what did we do right? What was that critical event? And I think it will be moving to an active monitoring system. I think it's the enabler, it's the Trojan horse, it's what will allow us to start finally talking to all the other HVAC components in a home that are all operating independently, sometimes conflicting with each other. With it? And so I think it's the main key. It'll reveal from a detection perspective that there's a problem, and we will be able to finally have something that's equivalent to a glass of water that's dirty. We'll be able to see it, but it'll be a digital glass of water.
True. Sartorius?
Yeah, I would like to add on Andrew's comment. Andrew, in some cases, people, they don't learn by the mistakes. We have already seen what happened, for example, with smart building or some smart home industry. When Apple, Google, they tried to develop their own communication protocols in order to create those futuristic houses or apartments, and they failed because they scattered so much the market that people get so much confused on what they should use, and now they're struggling. Eventually, they created Matter, let's say, where all of those companies went together, so joined their forces in order to create products that they can communicate, like you're saying, with each other, whether this is an HVAC system, an air purifier, an air quality monitor, a humidifier, or whatever the case will be. And we are in that situation at the moment, that we are learning that we have to come together again and build something similar.
Yeah, I don't agree with you, but most of their focus has been on toys, alarm systems, on lights, and put those industries down, audio systems, entertainment systems. They never touched the stuff that we're doing, the heavy lifting stuff of what is it that we breathe and experience and absorb when we're inside.
Absolutely.
And that's why I think this is the most critical field of them all.
I agree.
Agreed.
I think,
Stephanie, yeah?
I think one point is very clear. We need more capacity building, starting in the schools. In Germany, for example, where they're not very friendly in front of technology, we have to change a little the mind. Everybody's working with technology, but they don't like technology, and even the teacher are not very technology friendly. And I think, therefore, we have to, as many of the colleagues here talk like we, is to say we have to start or to stop and let's say reboost and say, hey, let's start again. Capacity building is important issue, important point, and make clear there very, very clear that we have this problem and that we can change the things to improve this situation. I think that's important issue. Start with the youth people.
Okay. Peter, you had raised your hand. Go ahead.
Yeah, I think we have to agree on a starting point, and I really felt the ASHRAE 241 is a great starting point. Talking about if you read through the standard, it talks about assessing first, and then. So I do agree with Dr. Taylor, meaning that we have to go in and actually take a look to see what is necessary to upgrade the indoor air quality, and then getting it to that standard. So, and it could be a wide range of different things following the ASHRAE 241. But I think the map is there. I think that the roadmap is there. Yes, the 241 is probably going to be tweaked a little, and we need to continue to try to get it even better, make it better. But at the end of the day, from a governance standpoint, it's implementing ASHRAE 241, and they can tie that. It's difficult to try to say, let's get some federal grants or money for what? For the clearer we are on the goal, the easier it is. We have more leverage of getting the funds, right? So if we know the target is specific ASHRAE 241, then it's easier to collect those funds to implement something, right? Instead of just saying, let's all decide on better indoor air quality or try to figure out, data or whatnot. That's how you get funding, is to target a goal, and it's easier. It gives us more leverage. So that's all I had to say.
Thanks, Peter. Stephanie?
So in response to what Peter, you just said, I agree with what you just said about having a clear goal. But when we choose a target, whether it's 241 or 44P or whatever it is, let's make sure that it's truly based on health data. So because I don't want to see us perpetuate incorrect standards. And I'm not saying 241 is incorrect. It doesn't talk about humidity, which concerns me, but it's a good start. But I also had a comment. This isn't a solution at all. It's more of a commiseration. I think as medicine becomes more specialized, as engineers have more specialized knowledge and technology and data science and microbiology, it's really hard, in my experience, to cross silos. So when I went from medicine to architecture school, it was a very difficult and uncomfortable experience to go from feeling proficient in a field to being a newcomer. So I just would encourage all of us to have compassion when we approach other professions. I think it's hard to do. in my experience.
Let's
That was
see.
what I wanted to
Let's
say.
see, Sartorius, you had your hand raised for a while.
Yeah, I would like to ask Stephanie a question because this is something common that I've been encountering lately. You've mentioned about like having a health approach. What limits should we adopt, for example, when it comes to air quality? But in some cases, in conversations that I have with other scientists out there, it's always like we don't have enough data to support. Let's say we would like to include the specific particle sizes that we know that they are smaller, they don't translate very well into mass, and by relying on solely on PM 2.5 is not sufficient in order to understand what's happening with the air we breathe. But we don't have enough data yet to come to a conclusion and to a specific number and say that, let's say, 10 particles per cubic centimeter maybe create some problems for the human health. How can we navigate these kind of difficulties when it comes with pollutants that we still don't have an understanding because we haven't measured them in such extents as some others?
So I
Uh,
hear what you're asking, and it is complicated, but I disagree that we don't have the data, because we do have the data. We have data on how compounds penetrate cell membranes, not only individual compounds such as PM, but what happens when you have ozone, low humidity, and particulates in your environment. You're in big trouble. But the fact of the matter is those data points do exist. They exist in cell biology, they exist in microbiology, they exist in metagenomic analysis of cells, but we have to bring these different professions together to understand them. But I don't think we can say we don't have enough data. Or
Okay.
at least let's start where we are and make progress, looking at
Okay,
individual
thanks.
and combined.
Okay, thanks very much, Stephanie. Appreciate that. We have just a few short minutes left here, and I just wanted to ask each one of you for your closing comments, and we'll start with you, Stephanie.
Oh, I just want to say I'm really grateful for this group, and I feel like even though we have slightly different angles, we're all moving in the same direction. So I just want to say thank you, and let's keep going.
Thanks very much. Peter.
Yes, I agree. I'm very humbled to be on the panel with all of you, and I agree with Dr. Taylor in the fact that communication in between different trades and degrees and doctors and talking to engineers is so critically important for the future of indoor air quality. That I think it's sometimes often overlooked, and I think we need to strengthen that as well. And I think we could strengthen it together using what I feel ASHRAE 241 is a great starting point. So,
Okay. Thanks very much, Peter.
Yeah.
Andrew, real quick here.
Yeah, I'm so grateful to be part of this group. This is pretty exciting, and maybe it starts here. Maybe we're the catalysts. I think from a mindset, this is a generational solution. We can't think short. Too many components, too many things to do. And if we think, incrementally, we will get there, and we'll probably have some breakthroughs along the continuum. But this is a longer term issue. It'll take a lot, and we just have to stay on it.
Agreed. Thank you very much for that. Sartorius, real quick.
Thank you. I think this filtration error has illuminated the complex web of factors influencing air quality and its profound impact in our lives. The challenge is significant, but our collective capacity for positive change is even greater, I think. And here I would like also to thank you and Dr. Iyad and the World Filtration Institute for the honor of being selected for this exceptional panel.
You're most welcome. Thank you. Dr. Peters.
Yeah, I think what we see very clear and have to underline is that contaminated air is a health risk. So we have to do everything to optimize the purification of the air, number one. We know, and that's the point that starting to be political, that we have to reduce or avoid contamination. But as more people like we help other to understand this, that we have to avoid and contamination of the air, is a step by step going forward. But finally, I think that, and that's what I hopefully could show, is that there are good technologies on the market that could be applied very well to this problem, and that we need, as my credo is really, we need more and better technology. I have to repeat this one, because that's what I learned in the 40 years I'm working as consultant now for water treatment. Also there, the people started at front, no, never, never, never. And now what's happening? They're reusing water for drinking purposes. That's not a story, that's reality now. And that was unbelievable few years ago, that somebody in the United States said we drink our wastewater again. You have to think about this one. And that's the point. I think that we have to be optimistic and positive and say, we will find a solution if we join forces. And therefore, I think, Stephanie, I agree with you completely. We need to work with the people and to have and we will find a solution to this problem. Thank you.
Okay. Thanks, Dr. Peters. Vijay, real quick, and then I'm going to have a closing statement from Dr. Iyad. Vijay, we can't hear you.
You muted me, so I didn't unmute. No, I was going to say it's been a pleasure to be on this group. Well, I think, like Dr. Peters says, we are where water was maybe 50 years ago, and it's a generational. It's not going to be immediate. The only thing I will say is to echo the flip side of what Stephanie said, we are all in different disciplines. We have to be careful in using or misusing terms from other disciplines. For example, none of the PM particle sensors, indoor air sensors measures PM at all. None, zero. So be careful what we use. And there is no such thing as HEPA-like.
Dr. Iyad.
Thank you, Mitch, and sincere appreciation to all our panelists. I think we have to also thank our moderator, anybody who can navigate through 6 bright minds. It's a tremendous job. I wanted to say 2 things. WFI will continue to bring difficult topics like air quality governance to the table. We need to find solutions. We may not today have definitive solutions to every single indoor air quality problem, but we will. The future is bright. We've got the technology. We have what it takes. As I said earlier, we borrow the earth from our children and grandchildren. So we certainly need to pass on to them a planet that is both clean and green. Filtration Hour is always an ideal spot to exchange this sort of conversation. Anybody who's been in the attendance has certainly come to the conclusion, as Andrew has said, there are too many parameters, there are too many moving targets. Yes, we don't have maybe all the solutions today, but certainly we've got so many tools in the box, we can do it. So again, thank you to Dr. Sun for facilitating this tremendous meeting, and I look forward to seeing all of you. Thank you.
Thank you,
Thanks,
everyone.
Iyad. Thanks, Mitch.
Thank you.
Yes, thank you very
Thank you,
much.
everybody.
And-
Thank you all. Thanks,
Right.
Mitch.
And for those that are in the audience, just as a reminder, we have a number of different courses that we offer that can address specific issues in filtration. I'd like to acknowledge all of our WFI members. Thank you very much. Without them, we could not have this program. I want to thank you panelists again. Without you, we certainly couldn't have this program. So thanks very much, and thanks for attending and your fantastic input. Thanks. Bye-bye.
Thank you. Take care.
Thank you.
Mitch.
Bye-bye.
Thanks, everyone. Be safe,
Tschüss.
Likewise.
Cheers.
Pass auf.
Same to you.
especially
Cheers.
you, Sotirios, with what you got going on near you.
Thank you. Thank you.